Action.
Well, hello there! Today I'm going to talk about the laws of thermodynamics. Well, I'm just going to the first law. Well, it's not exactly the first law. You call it the zeroth law. You know, the one before the first. Alright, the zeroth law of thermodynamics states that if an object A is in thermal equilibrium with object B, and if the object B is in thermal equilibrium with object C, then it is said that object A is also in thermal equilibrium with the object C. You know what I mean? It's just totally reversible. The first law. The first law, which is like a very important law, states that the energy can neither be created nor destroyed, which means energy is conserved. For example, see, energy in this man is 5 units, and the energy stored is 1 unit, and the energy out when he's walking is 4 units. Now the second law. The second law is a very important law which states that heat can only be transferred from a hot body to a cold body. It can never go from a cold body to a hot body. It's impossible. Alright, and the third law of thermodynamics states that the entropy of any pure substance in the thermodynamic equilibrium approaches zero. It approaches zero as the temperature approaches 0 Kelvin, which is said to be impossible. Alright, now let me get back to my topic. What I'm talking about is the first law of thermodynamics. Well, there's a very important equation right over here. Alright, delta U, which is the change in the internal energy, is heat added to the system minus the work done by the system. And now, we know that energy in this universe is conserved. But energy sources actually involve conversion of energy from one form to another, rather than creation of energy from nothing. For instance, chemical energy in the coal is transferred to thermal energy. Then thermal energy is converted to kinetic energy in steam, as in steam, you know. And the kinetic energy is converted to mechanical energy in the turbine, over here, in the turbine. And the mechanical energy of the turbine is transferred as electrical energy, which is the ultimate output. Now, there are many other examples, like thermoelectric, which is heat to electricity, geothermal power, which is heat to electricity again, and ocean thermal power, which is heat to electricity again. And let's go to something else. Yeah, hydroelectric dams, which are gravitational potential energy to electricity. The fuel cells are chemical energy to electricity. Microphone is sound to electricity. Nuclear power plant is nuclear energy to heat, and from heat to electricity. Solar thermal is light to heat. Wave power is mechanical energy to electricity. Windmills, like wind energy to electricity or mechanical energy, anything. Now, Einstein's famous equation describes the relationship between energy and matter. The first law of thermodynamics is mainly, it obeys the law of Einstein's E is equal to mc squared. In the equation, E is equal to matter, m times the square of a constant c, which is the speed of light. Einstein suggested that energy and matter are interchangeable. His equation also suggests that the quantity of energy and matter in the universe is fixed, which takes us back to the first law of thermodynamics. Now, I got an interesting video for you. Well, let's get to the video. Pause it.
The first law of thermodynamics. Heat is work and work is heat.
Heat is work and work is heat.
Very good. The second law of thermodynamics. Heat cannot of itself pass from one body to a hotter body.
Heat cannot of itself pass from one body to a hotter body.
Heat won't pass from a cooler to a hotter.
Heat won't pass from a cooler to a hotter.
You can try it if you like, but you'd far better not.
You can try it if you like, but you're far better not.
Cause the cold in the cooler will get hotter as a ruler.
Cause the cold in the cooler will get hotter as a ruler.
Because the hotter body's heat will pass to the cooler.
Cause the hotter body's heat will pass to the cooler.
Heat is work and work is heat and work is heat and heat is work. Heat will pass by conduction and the
Heat will pass by conduction.
Heat will pass by convection.
Heat will pass by convection.
Heat will pass by radiation.
Heat will pass by radiation.
And that's a physical law. Heat is work and work's a curse. And all the heat in the universe is gonna cool down. Because it can't increase, then there'll be no more work and there'll be perfect peace.
Really?
Yeah, that's entropy, man. And all because of the second law of thermodynamics, which lays down that you can't pass heat from the cooler to a hotter. Try it if you like, you far better.
Cause the cold in the cooler will get hotter as a ruler. Cause the hotter body's heat will pass to the cooler.
Oh, you can't pass
from the cooler to a hotter. You try it if you like, but you'll only look a fool. Cause the cold in the cooler will get hotter as a ruler. That's a physical law.
Oh, I'm hot.
What? That's because you've been working.
Oh, Beatles, nothing.
That's the first and second law of thermodynamics.